Hello, it's my sisir and I'm going to have a mandatory tutorial on FPGA based on hardware and software code design and its exploration. Um, The main goal of these tutorials are know what is hardware or software code design, explain its past, present and future, know what the design space exploration is, know the system on chip. What is hardware software code design? The meeting of system-level objectives by exploiting the trade-off between hardware and software in a system through their concurrent design is known as hardware-software co-design. It helps in the concurrent development of the hardware and software and in the integrated system. Co-design emerged basically as a new discipline to design complex integrated circuits in the early 1990s, used for the programming of any ICs at that time for microprocessor. Hardware or software co-design techniques have become a must for a successful electronic system designed today, more in companies than that are developing embedded electronic system products. The slowdown of technological progress will also justify to spend more design time on a careful analysis and exploration of design options as per the Moore's law. Now let's discuss on importance of co-design. The main importance of co-design are improved design quality, design cycle time and the cost, reduced integration time and the test time, supports growing complexity of embedded system, takes advantage of advance in tools and the technologies, processor codes, high-level hardware synthesis capabilities, SC development. Now, what are the necessaries of co-design? The necessaries of the co-design are as follows. Most systems today includes both dedicated hardware unit and the software units. Programmable processor begin used in the system. Solve dependability issue of system with trade-offs and interplay. What are the co-design features? The features of the co-design are as below. Enables mutual influence of both hardware and software early in the design cycle. Enables evaluation of large design space, analyzing different hardware and software partition. Enable fast verification, faster exploration of the design space. Major purpose of hardware software co-design. The major purpose of the hardware software co-design are in four number. They are coordination, concurrency, correctness, complexity. Coordination, to work together on all parts of the system. Concurrency, to work concurrently instead of starting the firmware and the software development as well as their test only after the hardware platform. Correctness, complex hardware and the software require techniques to not only verify the correctness of the individual subsystem but co-verify them. Complexity, close the well-known design gap produced correctly working and highly optimized system implementation. The early bugs, an essential step towards SLD automation of complex electronic systems started in the early 1980s and the early 1990s. A research communication community was started in 1992. A procedure of concurrent and coordination design of an electronic system comprising hardware as well as software component based on a system description that is implementation independent by the aid of design automation. The first IFIP International Workshop on Hardware Software Co-Design took place in Zürich, Germany, and the first generation. We can see a figure below having CPU, memory, and SC. Let's have a short description about that. A set of communicating models or tasks specified in a C like dialect is mapped onto a given hardware platform consisting of single processor, central processing unit (CPU), a user-defined application-specific hardware block or application-specific integrated circuit (SC), with both parts communicating over a bus, a shared memory or transistor for buffer implementation. Now the second generation. It has more than one CPU, multi-processing and multi-programming, and the co-simulation. Co-simulation problem lies in coupling different models to make the hardware simulation sufficiently accurate. Co-design is an ideal way to explore the design space and create a suitable platform architecture. And now in the today, we live in a third generation of co-design technology. It has class-level design environment for the synthesis of complex electronic systems, mainly driven by the following system design challenges. A heterogeneous system on chip technology has greatly evolved up to nanotechnology and a multi-billion single system on chip transistor. Hardware and software complexity. It is not only founded for system on chip technology on a single chip, but also at the level of distributed communicating electronic device that is used by the current technology. C. Integration panic. Major goals is to facilitate the exchange and update of software and hardware over the service. What is design space exploration? Design space exploration has soon started to become a distinguishing elements of core design technology. The service space is given by the set of all possible permutation of allocation bindings and schedules. Any such triple satisfying a certain number of additional non-functional constants such as on cost, performance, power, temperature is called the feasible solution. System design, system exploration, as the name says, is the task to explore the system set of feasible implementation. There one efficiency to finding of not only of these but through many and also for the optimal ones. Problem problem associated with the design space exploration. The main problem associated with the design space exploration are as follows. Exploration cost and exploration strategies. Any known such techniques and strategies may be applied to find a feasible implementation. Multi-objective nature and evaluation of non-functional properties. Provide a weighting function to combine both objectives into one function which corresponds already to decision making by the designer. Trade-off for implementation. Trio multi-objective exploration technique. How to feasibly evaluate the quality of a design point. Vast research space, flexibility, objective may be specified. What is system on chip? A system on a chip is a microchip with all the necessary electronic circuit and parts for a given system, such as a smartphone or a wearable computer, on a single integrated circuit. System on a chip technology is used in small, increasingly complex consumer electronic devices. Such devices have more processing power and memory than a typical 10-year-old desktop computer. System on chip is evolving along with other technologies such as silicon on insulator, which can provide increased clock speed while reducing the power consumed by a microchip. Combine several components on a bus system. One of them is microprocessor, which acts as a central controller on system on chip. Other components are on-chip memory, off-chip memory interface, dedicated peripherals, hardware coprocessors, and component-to-component link. The application domain greatly affects the hardware peripheral size of memory and on-chip communication. Advantages of system on chip. There are two advantages of system on chip. They are specialization and flexibility. What is specialization? Specialization of platforms ensures that its processing speed is higher than that of general purpose solution, low power consumption, and flexibility. Flexibility of platform ensures that it is a reusable solution that works over multiple applications, cost per application decreases, and system on chip itself becomes cheaper. Cost of pairs. We can see a figure below which of architecture which can be analyzed along four orthogonal dimensions. They are control, communication, computation, and storage. Control. It is done by microprocessor responsible of issuing control signal to collecting status signal from and the various components in the system. Communication. It is done by system-wide buses, which is a bundle of signal including address, data, control, and synchronization signal. Computation. System on chip is split into segments and each segment is responsible of computing according to communication needed. Storage. Each bus contains a master and a slave storage. Design principle on system on chip architecture. There are four design principles on system on chip architecture. They are A. Heterogeneous and distributed communication. System on chip interconnection is high heterogeneous. Enables a designer to exploit on-chip communication bandwidth. The efficiency is not the same for off-chip communication bandwidth. The maximum bandwidth for communication port is around 51.2 GB per second. B. Heterogeneous and distributed data processing. It is the first prominent character of system-on-chip architecture. System-on-chip may contain multiple independent computational units. Has three forms of data processing parallelism. 1. Word level parallelism. Up 2. Operation level parallelism. 3. Task level parallelism. C. Heterogeneous and distributes storage. It is the third character of system-on-chip. System-on-chip uses a collection of dedicated memory. Processor and micro-coded engine may contain local instruction memory. Cache memory are also used. Local register files are used as memory. There are five types of memory available. 1. Register. It is the fastest type of memory, also called foreground memory. 2. DRAM. It is also called dynamic random access memory. It provides cheap memory at very high densities. 3. SRAM. It is also called static random access memory. It is used where fast read-write storage is required. 4. NVROM. It is also called non-volatile read-only memory. It is used for the application that requires read access only. 5. VRAM. It is also called volatile random access memory. It is used for the application that requires both read-write access and do not lose the data when the power is removed. Now the last is hierarchy of control. The final concept is the control among component. System on chip use the single logic entity to operate. Component operates independently but synchronized on some point and report to the point of control. Thank you for your attention and valuable time.